Climate change is already visible throughout the globe. The atmosphere and ocean temperature has increased, the precipitation patterns have changed, the amounts of snow and ice have diminished, and sea level has risen, while extreme weather events like floods and drought have increased in intensity and frequency. These changes incur in their turn impacts to the various sectors of the economy, to the environment and the societies as well. Adaptation to the adverse effect of climate change is necessary in order to reduce the vulnerability of natural and human systems, to enhance the viability of social and economic activities, and to eliminate, at the degree possible, the impacts from extreme climatic phenomena. Adaptation consists of actions for protecting against adverse impacts and minimizing the damage they can cause, building resilience, and taking advantage of any opportunities that may arise. Recognizing the need for timely addressing climate change impacts in Cyprus and strengthening the country's adaptive capacity, the LIFE+ project, development of a national strategy for adaptation to climate change adverse impacts in Cyprus, was developed. The project initiated in September 2011 and has a duration of 31 months. The Department of Environment, Ministry of Agriculture, Natural Resources and Environment of Cyprus is the coordinator of the project, while the National Technical University of Athens and the National Observatory of Athens are project partners. The project is co-financed by the LIFE+ program, the EU financial instrument for the environment. The project focuses on all those sectors of Cyprus that are affected or expected to be affected in the future by climate change, namely water resources, agriculture, biodiversity, soils, forests, coastal zones, fisheries and aquaculture, energy, tourism, public health, and infrastructure. The project is structured upon the following 6 actions. Action 1. Assessment of the current vulnerability of Cyprus to the observed changes in climate. Action 2. Assessment of the future vulnerability of Cyprus to the expected changes in climate. Action 3. Identification of the available measures for the adaptation of Cyprus to climate change impacts. Action 4. Evaluation of the proposed adaptation measures for the selection of the most appropriate ones for the case of Cyprus. Action 5. Development of a national strategy for the adaptation of Cyprus to climate change. Action 6. Monitoring and evaluation of the implementation of the national strategy. For the successful implementation of the project, the active engagement of stakeholders and the awareness and information actions in all steps of the process is of the utmost importance. The development of a sound and commonly accepted national adaptation strategy is a complex process, as it requires the integration of the opinions and the involvement of multiple decision makers from different sectors and experts from diverse disciplines, as well as the evaluation of various adaptation options based on multiple and potentially conflicting criteria. To overcome this challenge, a multiple criteria analysis software tool was developed in the framework of the CYPADAPT project. The MCA method constitutes a decision support tool which enables evaluation of measures against several technical, environmental, social and economic criteria, consultation and engagement of a broad spectrum of stakeholders and experts in the decision-making process, depicting and understanding stakeholder and policymaker preferences, reaching a compromise or defining a coalition of views, and undertaking consistent and transparent decisions. The CYPADAPT tool processes stakeholder evaluations on the proposed adaptation measures and produces alternative adaptation scenarios based on the degree of vulnerability of the system to climate change, the weights assigned to the evaluation criteria, as well as the weights assigned to the different stakeholder groups. Following, the operation of the CYPADAPT Multi-criteria Analysis tool is presented. The software operation does not require any kind of installation. The only precondition is the pre-installation to one's computer of the Excel from the MS Office suite package. An extra requirement is the activation of the macro commands in Excel itself. If the commands are not activated, then a safety warning will appear at the top side of the screen. Pressing the key options, a new window of this form appears. The user can choose the option Activation of this content and press OK. As the program starts, the user first sees an introductory page, in which there are basic elements of the program, such as the structure of the software, user manual, rating scales, etc., while at the top of the page, the user can find keys with which he or she can easily navigate throughout the software. More specifically, the structure of the software is divided in 5 basic parts. The introductory page, which is the current page and provides general information and user guidance. Entry of general data, criteria weighing, rating or evaluation of the adaptation measures for all fields of interest, and finally, the results, sensitivity analysis. By pressing the Start key, the user is led to a page where he or she must fill in general data, such as the organization he or she represents, the department, etc. These data can be entered from predefined lists which already exist in the program database. As in every case of multi-criteria analysis, a weight coefficient is assigned to everyone involved, depending on his or her role in the decision process, as well as on his or her scientific field of expertise. In the Tools section, 9 categories of bodies have been predefined, to which particular weight coefficients have been attributed. These coefficients can be changed at will by the user. By pressing the next key, the user is led to the criteria weighing page. In this page, 8 basic criteria have been defined, divided into 4 groups: technical, environmental, financial, and social criteria. Here, the user can choose which of these criteria he or she wants to include into the decision process, together with the corresponding weight he or she wants to attribute to them. More specifically, the user defines the weight of every criterion in a scale from 0, which means that the criterion will be ignored by the process, to 100. The calculation of the percentage contribution of every criterion in the final evaluation is carried out immediately, and the final criteria weighing is shown in the figure to the right. By pressing the key Next, the user is led to the page of the first sector, which is energy. In this page, through a compiled questionnaire, the user attributes to every criterion and measure the rate he or she prefers. More specifically, the user rates with 1 the least preferred option and with 100 the best alternative, in agreement with the scale you see as follows. For example, as the user reads the measure Increase for the conventional energy production with the use of new production units and the decommissioning of old units, he or she considers that the measure for the criterion Environmentally friendly is very good. Based on the scale which appeared previously, he or she will attribute a grade between 60 and 80. In the case of the criterion Financial Sustainability, 1 represents the cheapest and 100 the most expensive measure. If the user does not want some measure to be included in the list, then he or she leaves the corresponding cell blank. As mentioned before, the program provides a database from pre-filled questionnaires. In case the user wants to enter the values from the database, then he or she will have to press the key Copy values from database. In this way, this program automatically enters the values that have arisen from the completion of the questionnaires, which had been done by various bodies during the relevant consultation of the program CYPADAPT tool. By pressing the key Next, the user can navigate to all 11 sectors which concern the program. More specifically, the next sector is tourism, while the rest are agriculture, biodiversity, fisheries, forests, infrastructure, public health, soil resources, water resources, and finally, coastal zones. After the user rates the measures which interest him or her for all or some of the sectors mentioned, then by pressing Next, he or she is found in the page of General Results. In this page, the user initially sees the final weighting of the criteria, while directly below the list, the results of the multi-criteria analysis appear. The sector is mentioned in the first column of the table, and the measures appear in the third column. In the fourth column, the value which resulted from the analysis appears, based on the user rating in the questionnaires that have preceded. In the fifth column, the degree of importance appears, which has been attributed to the measure through relevant scientific research, while the final score is found in the sixth column of the table. The user, using the key Rank from higher to lower in the column Final Score, can proceed to the ranking of the measures according to the final rating. In this column, the user sees the number of questionnaires completed during consultation, while in the previous column he or she can see in how many of the total questionnaires the corresponding measure was rated. This occurs because some people who were questioned rated every measure that existed, since not all measures fell within their field of expertise. In the last column, the measures which can appear in more than one sector are shown. No particular emphasis is given to these measures through the software. Instead, they are identified so that the user can evaluate them should he or she feel it is necessary. For example, in this particular case, first in ranking is the measure Maintenance and Repair of Water Transport Systems and the relevant infrastructure, adoption of technologies for identifying leaks and control, which belongs to the sector Water Resources. According to the multi-criteria analysis and the scenario chosen, this measure has a final score of 432. Also, it is noted that overall in this sector, 21 questionnaires have been completed, and in 19 of these, the subjects have given this measure a rating. The remaining 2 did not give a rating because it was outside their field of expertise. It is apparent that if, for any reason, there is a change in the criteria weighing in the multi-criteria analysis, the final result will change. For this reason, it is very important at this stage that the user, regardless of the criteria he or she has chosen, can change the criteria weighing and navigate between different scenarios, and see directly the effect of every change on the final ranking of the criteria. Apart from the scenario created by the user, the 3 additional scenarios predefined by the program are: the environmental scenario, where environmental criteria have higher importance; the technical scenario, where higher importance has been attributed to technical criteria; and the weighted scenario, where the financial criterion has been excluded and the importance of the remaining criteria is evenly distributed. Apart from these scenarios, the user, by pressing the key Change, can re-enter the criteria weighings in the relevant page and form a new scenario. Then, by pressing the key Result, the user returns to the page of the general results. By pressing the key Next, the user is led to the analytical results per sector. In the upper part of the page, there are keys through which the user can easily navigate in the analytical results in all sectors, while below the final weighing of the criteria, the scenarios and the results table of the sector are presented. The sector is mentioned in the first column of the table, and the measures appear in the fourth column. In the fifth column, we have the value which resulted from the multi-criteria analysis based on the user rating in the questionnaires that have preceded, while the final rating is in the seventh column of the table. The user, pressing this key, can perform the measure ranking based on the final rating. As in the general results, here the user sees statistical data about the questionnaires, while in parallel he or she can navigate between different scenarios, environmental scenario, weighting scenario, etc., and see directly the effect of every change on the final ranking of the criteria. Additionally, the user can carry out here a sensitivity analysis. Generally, the sensitivity analysis is a tool which checks on the variation of the final ranking in data change, such as criteria weighing. Thus, the user can directly change the criteria and see in real time the variations that take place in the final ranking. This analysis is an extremely useful tool for the user, because in this way he or she can detect the differences which exist in a scenario change, can directly detect how the final result is affected, and can find measures with stable final ranking, and therefore less sensitive to scenario change. In this page, the user can additionally find a statistical analysis of the results of the database. In the particular example, we see that the questionnaires were completed by 8% by participants from the competent authority, by 15% by universities and research institutes, and so on. The next 8 diagrams present the fluctuations of the rates attributed to each criterion for every measure and for all participants. The measures are shown on the x-axis, the rates given from 1 to 100 are shown on the y-axis, while every line represents one respondent. The red line shown here gives us the mean result which arises. For example, in the diagram of the first criterion, we see a total of 17 respondents, while the rates they gave to measure 1 ranged from 40% given by respondent 12 to 100% given by respondent 11, with a mean value of 70%. the large fluctuations do not necessarily constitute an error indication, e.g., not understanding the measure or scale, but can mean an opposite view between the participants, which happens often. In general, it is suggested that, when diagrams with large fluctuations appear, particular attention is paid to the measure which presents this phenomenon, and to be examined separately and autonomously. This will ensure the elimination of the possibility of calibration error and the rejection of the results which are based on potentially erroneous extreme values of measure rating. The user pressing the keys located at the top of the page can easily navigate in the analytical results for the remaining sectors, while, by pressing the key X, he or she can terminate the program at any time. In conclusion, the multi-criteria evaluation tool, which was developed in the frame of the CYPADAPT project, gives the users the possibility to evaluate different adaptation measures on a national level, and additionally, allows cooperative decision-making, embodying the evaluations of a multitude of participant bodies. For this reason, it is a very useful tool in the development of strategic plans of adaptation in the field of climate change,